Okay, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, and today we are going into the WireShark Packet Operations room, which is inside the pathway of SOC Level 1 Security Operations Center Level 1 for the junior analyst role. And this is going to be a part of the WireShark Basics packet operations and trend analysis or traffic analysis. Excuse me. It's like a three-part series for WireShark. We already did the WireShark Basics, and you can find that video on my channel. I'm gonna try to put the link in the description below. And today we're gonna go into packet operations, and then the next one is gonna be the traffic analysis. This is a subscribers only room, which means that you need a paid subscription with TryHackMe, which is 12 bucks. If you use the link in the description below, it'll drop 5 bucks off of that, so it'll bring it down to 7 bucks for you and make it a little bit more affordable to get a paid membership with TryHackMe, and then you can get access to all of the VIP rooms and all of the free rooms that they have. And there's a lot of great rooms and a lot of useful tools and machines and stuff like that. So in my opinion, it's definitely worth it, and you're more than welcome to just download WireShark on your own machine and find some sample PCAP files that you can use from GitHub or any of these other places that you can use to kind of go along with the video that we have, as well as you can just capture traffic from your own machine, from your own interface, and then use that PCAP file to do the analysis and all the stuff that we're going to be doing. So it's fairly easy to actually run this thing, and it is for free. So either way, no matter which direction you end up choosing, you'll definitely have something to work with. And of course, if you like, subscribe, and turn on that notification bell, then you'll get notified the next time a video comes out, either in the current path that we're on or the Pentest Plus path. And then as we progress and we just get more into the intermediate and advanced stuff, then you'll just have access to all of that. And I would very much love to have you as a part of our community. So it would be really, really awesome to just be able to kind of tag along with you, or you can tag along with me as we go through this journey. All right, so the introduction of the room goes as follows. So in this room, we're going to cover the fundamentals of packet analysis with WireShark and investigate the event of interest at the packet level. Note that this is the second room. So I already mentioned that we did the WireShark Basics, and you're more than welcome to go check that out if you haven't seen it already. In the first room, we covered just basically how WireShark works and how to investigate traffic captures. In this one, we're going to go into some advanced features by focusing on packet level details with WireShark statistics, filters, operators, and functions. And a virtual machine is attached to this room, and this is what you see on the side right here. I've already started it up. It takes a couple of minutes to start up, and it comes pre-installed with a copy of WireShark, as well as the exercise PCAP file, which is on the desktop right here. And that's, I think, what we're going to be working with. There was no other PCAP file to work with, so I think that's basically what we're going to work with. And yeah, that being said, let's jump into the actual content of the room. So the statistics summary. This menu, with the statistics menu, provides multiple options ready to investigate to help users see the big picture in terms of the scope of the traffic, available protocols, endpoints, conversations, and some specific protocol detail or protocol specific details like DHCP, DNS, HTTP, etc. For a security analyst, it's crucial to know how to utilize the statistical information. This section provides a quick summary of the process PCAP, which will help us create a hypothesis for an investigation, and you can use statistics menu to view all available options. So start the VM and use the exercise PCAP, which we already did. So the first thing that we want to do is we go to statistics, resolved addresses, and it'll bring up this menu for us, and it's going to show up the IP as well as the specific page that was visited, so the DNS version of the IP address that was visited. And there's mostly it seems interesting. There's test PHP von web, which might be kind of like a weird domain that might not be a good domain to be visiting, so on and so forth. This is an IPv4 address. This is an IPv6 address. And then we have the protocol hierarchy, which is also under the statistics menu. And you just click on that and it gives you the hierarchy of the protocols that were visited. And it gives you percentages of how many different types of packets were there. So you have the IPv6, which was nothing, and then there's Ethernet, IPv4, and then there's TCP, Transmission Control Protocol, and then Hypertext Transfer Protocol, which is HTTP, which is like 1.9% of what was available, and then the percentage of the bytes, so on and so forth. And then we have conversations, and conversations basically mean the source address with the source port and the destination address with the destination port, and what kind of conversations have been had. So under statistics, again, we just go under conversations, and then there's the IPv4, IPv6, TCP, and UDP conversations. And so this is just a view of the IPv4 with address A being the source address, address B being the destination address. And then if you go further down under TCP, we can see the address A with the port, address B with the port, the packets, the bytes, so on and so forth. Then you have the endpoints, and that's also under statistics. And then when you click on that, it shows you the various endpoints, which in this case are MAC addresses. And you have each MAC address dedicated to a specific thing. So if you click on name resolution, it'll show you the device that's attached to that MAC address. So for example, a Xerox, I guess a printer or whatever it is. So it gives you more detail on top of whatever the MAC address is. And then if you notice, there are certain ones that don't have the name attached to it. It just has the MAC address that's attached to it. It's not limited only to MAC addresses, as it says. It provides IP and port name resolution options as well. However, these are not enabled by default. If you want to use these functionalities, you need to activate them through Edit Preferences Name Resolution menu, and then we can resolve for transport names as well as IP addresses, and then I think there's maybe even something for ports. So it's all under Preferences for Name Resolution. And the default installation looks like this. So you click on something, and if you double click it, it'll kind of show you the source IP. My apologies. So this is what the default install looks like. And then when you turn on IP port and name resolution, it gives you the name, dial in, whatever, including the port that was attached to it. And then so it says TIP, the port number, going to HTTP, the port number, versus over here where it just said the port number going to port number. This one actually gives you TIP2, HTTP in addition to the other part, where this is 145.254, this is dial in 145.254. So it gives you a little bit more information, which is useful. It can be very useful. So the endpoint menu has the name resolution option as well, and so you get to kind of see the difference between the two. So on this side we have the without name resolution, and on the right side we have with name resolution. So 4222 ends up resolving to bresolvers lever3.net. 10.10.47.123 ends up resolving to whatever this is right here, compute internal Europe. It seems like a name server that it was sent to, and so on and so forth. And so you have both versions of it that can be just turned on with the click of a button, which is a little bit more useful. And of course, if you want, so let's just read this piece right here. It says, beside name resolution, WireShark also provides an IP geolocation mapping that helps identify the map's source and destination addresses, but this feature is not activated by default and needs supplementary data like the GeoIP database. Currently, WireShark supports MaxMind databases, and the latest versions of the WireShark come configured with MaxMind DB resolver. However, you still need MaxMind files, and provide the database path to WireShark using Edit Preferences, Name Resolution, MaxMind database directories. Once you download and indicate the path, WireShark will automatically provide GeoIP information under the IP protocol details. So this is where it would fall under. So when you go to IP version 4, there's several layers to this, several options to this. When you click on IPv4, it'll give you at the bottom source GeoIP, so on and so forth, destination GeoIP, so on and so forth. And then we have endpoints and the GeoIP view. So under the endpoints menu, when you go on IPv4, there's going to be a couple of columns for the country and the city, and then we can obviously open it, well, not obviously, but very conveniently, it's available that we can open it inside a browser so that we can see what it actually looks like on a map, which is kind of cool. So we need an active internet connection to view the GeoIP map. The lab machine does not have an active internet connection, so we're not going to be able to actually look at the map or anything like that. We're just going to be able to analyze the packet and try to get the answers to these questions. So that being said, I'm going to jump into the actual exercise itself, and we can kind of go from the top just to see what kind of answers we can generate here. Okay, so just to make this a little bit easier, I'm going to open this up in a full screen window so that we can actually get better access to the WireShark interface, and it makes it just easier to go through a lot of detailed information since there's a lot of lines and there's a lot of things going on. So I'm just gonna read the questions on my secondary monitor, and then from here we're going to go through all the information, answer the questions, and then at the very end we'll just review the questions. So the first one is investigate the resolved addresses. What is the IP address of the host name that starts with BBC? And the hint says that resolved addresses helps. So since we're going to be with the statistics menu, we're just going to go to resolved addresses, and we're looking for something that starts with BBC. So let's see what we can find. Doing a quick search in the search menu right here, it says there's only one option that actually starts with BBC, and so the IP address is this field right here, and it doesn't seem like I can copy it, so I have to manually type it into our answer. So 199.232.24.81 is going to be that one. Now it says what is the number of IPv4 conversations, and that one we're going to find inside the conversations tab menu. So statistics, conversations, and that'll open it up right here, and we want IPv4. So the number of IPv4, it literally says it at the very top right here, so we don't even need to click on that. So it's going to be 435 is going to be the answer for that. How many bytes in kilobytes were transferred from microST MAC address? And that is going to be in the endpoints and name resolution. So we're going to open up endpoints specifically, and with endpoints, again, under statistics, go to endpoints, and we want to turn on name resolution at the bottom right here so that we can actually see it. And then there's going to be a number of bytes in this. There's a column 4 bytes, and so what we're looking for is microST. So if I guess this is this alphabetized? It doesn't seem to be. So maybe that is alphabetized now. Let's try to find microST. There is microST, and so the number of bytes is 7474K. So 7474K. There we go. What is the number of IP addresses linked with Kansas City? And so we need to go back into endpoints, which is where we are, and we want to find under Kansas City. So how many are under Kansas City? And let's see. So we're going to go into IPv4. It hasn't specified whether it's IPv6 or IPv4. IPv6 only has Czechia as the country, and nothing even remotely close to Kansas City. So we're going to go into IPv4. We're going to click on city and try to come down to K to see if we can find. Oh, I have passed it already. And so how many options do we have for Kansas City? 1, 2, 3, 4 are the options for Kansas City. So that should be the answer for that, and that's that. And so it says which IP address is linked with BlickNet AS organization, and that's also under endpoints and BlickNet AS organization. So AS organization is the tab that we see right here. And so we're just going to organize this one and see if we can go and see what's under BlickNet. So there is one thing under BlickNet, and that's going to be this IP address. Can I copy this? I can't copy this. So we're just going to type that in manually. It's going to be 188.246.82.7. And that is correct. So very quickly, we just answered the first set of questions, and I'm just going to reload this page just so you can also see what we did. And it's going to be under statistics summary. So right here, these are all the answers. If you didn't believe that they were the correct answers, we just have all the confirmations right here. So this was in resolved addresses. This was under conversations, I think, right? Conversations, yep. How many bytes were transferred micro? This is all endpoints. This is also under endpoints, and this is also under endpoints. So pretty straightforward, honestly. So far, so good. Nothing complicated. And we can now move on to the next section, which is the statistics protocol details. All right, protocol details. So you have two versions of IP addresses. You have IPv4 and IPv6. And so under statistics, again, we can just go to IPv4 statistics and we can view all addresses, which is what this looks like. This is all the addresses. Then you can do destinations and ports, which will show you only the destinations and ports that are associated with them. And you can do IP protocol types. So if you open that up, it'll show you under the different protocol types, UDP, TCP, or no protocol. And then we have source and destination addresses, which is the combination of the two, right? So you have the source address as well as the destination address right here. And so it's kind of interesting that there's destinations and ports, but there is no sources and ports, but there is sources and destinations, whatever. But this is kind of what it looks like. So this is I mean, we don't really need to go crazy into trying to figure out what all of these things mean yet, because we're just going to go through it through the exercise. And then there is DNS information. So that's under DNS under statistics. And so you click on that and it gives you the individual topic / item that comes in, and then the count that is associated with that. So response query, service statistics, response stats, number of questions, authorities, etc. Fourth level, third level. So all these different things, payload size, all of this stuff falls under the topic item column. And then you have of course, the time associated with it, the minimum value, maximum value, so on and so forth. But it doesn't seem to be of note because they haven't put a little red line around it. And then we have HTTP, and under HTTP you have the packet counter, which is what this thing looks like. Shows you the total number of HTTP packets and then how it breaks down accordingly. And then we have the load distribution, which is what this looks like, and the number of counts associated with that. Then you have requests, which is what this looks like right here. There is no count associated with it, but it does show you what was requested within each domain and within each HTTP request. And then you have request sequences, which is what this looks like. And so I'm guessing it goes from test PHP to vuln web categories, and then under categories you go to artists, and under artists I guess there's more categories or another click that was made that went back to categories, but it's just within this entire sequence of stuff that was done. And then there was a bunch of images that was viewed and then went back to artists, so on and so forth. So it's the sequence of requests that was done on a particular website in a particular session. I'm going to say this is one session that this whole thing happened, and then after that they went into this IP address. So that's what that looks like. And so now we're going to start answering some more questions here, which is what is the most used IPv4 destination address? What is the max service request response time of DNS packets? And what is the number of HTTP requests accomplished by radmsn.com? And if you don't know what this means, this is a defanged DNS or defanged URL. And you can do this also with IP addresses where you just put square brackets around the dots so that it's not clickable. That's basically what that is. So that's what we're going to try to answer right now. So let me zoom out of this and go into our packets right here, and we can close this. And so the first one is, what is the most used IPv4 destination address, which is going to be under statistics, IPv4 statistics, and we're going to do most used destination address. So we'll just do destinations and ports, and we're going to go right here, and then we'll have a bunch of counts associated with it. So if I click on counts, I think it's still loading. There's a little bar down here that shows like it might still be loading. So we'll see. Yeah, it's still loading. I'm going to give this a quick second so that it can finish loading, and then once it's done loading, we'll try to find which one the most viewed IPv4 destination address is. Okay, there we go. So we got that. So now we're going to click on count one more time, and then click on count one more time, and there we go. So we have the most used, which is this thing right here, 10.133. That's going to be the answer. So 10.133. Very good. And what is the max service request response time of the DNS packets? And since they mentioned DNS, we're going to go into DNS statistics, which is right here. And we want, that loaded pretty quickly. So we want the max service request response time. So let's see what that falls under. Service, there we go. Request response time, that's what we're looking for. Okay, that's what we're looking for. So request response time in seconds, what is the maximum value? It's this thing, so 0.467897. That's what that is. 0.467897, and that is indeed the correct answer here. And so, last question, what is the number of HTTP requests accomplished by radmsn.com? And that is going to be under HTTP statistics. So we're going to close this out, go to statistics, and do HTTP. And what do we want? We want requests. So we're going to go to requests, and it should open this up for us right here. And we want the max under radmsn.com. So let's let it load real quick. And there's that. And so now I need to find radmsn.com. So just to kind of give ourselves a little bit more room to work with, I'm going to shrink down this menu because it's a very, they did it because I'm sure there's some very long IP addresses that are in there. I think I might need to actually maximize this just to make it a little bit easier. We're going to maximize that. I'm going to bring this all the way down. There we go. That's easier. And so now we can actually see all of the fields. And the big thing that we're looking for is radmsn.com. And this seems to be organized. So let's see if we can find radmsn. And there it is. So radmsn.com has 39 count. So there's 39 times that this was requested, and we got that. And there you go. That is indeed the right answer. So I'm going to shrink this back down. If we need to visit it again, we can just open it back up again. And we're going to refresh our page just so we can see that we got all the right answers under protocol details. And indeed, we did. Look at that. So, you already saw how we got those things, so I'm not going to go into further detail on what was done to accomplish those. So we're going to now move on to the packet filtering menu and look at principles. All right. In the basics of WireShark, we looked at packet filtering and how to filter packets without using queries. Now we're going to start looking at some queries to filter packets. There are two types of filters. Both use similar syntax. They are used for different purposes. So there is capture filters, and this type of filter is used to save only a specific part of the traffic. It is set before capturing traffic and not changeable during the capture, okay? And then there's display filters. This is after you've captured everything and you want to investigate the packets, reducing the number of visible packets. So capture filters happens before you start the capture, and then display filters happens after you've completed the capture and you're trying to go sort through your results. You cannot use display filter expressions for capturing traffic, and vice versa. Okay. The typical use case is capturing everything and filtering the packets according to the event of interest. Only experienced professionals use capture filters and sniff traffic. This is why WireShark supports more protocol types and display filters. Please ensure you thoroughly learn how to use capture filters before using them in a live environment. That's a good idea. Okay, so capture filter syntax, and I don't know if we're going to be doing this much, but just in case, it's probably good to go through it. So before you go to capture, you're going to go to capture filters, and this is on the menu, like the main menu of this, and we could probably even see it right here. So capture filters are right here. These are going to be all of our capture filters, the filter name, and the expression that you're going to use. So Ethernet address would be, for that Ethernet, you need to put ether host and then do that, right? No ARP, not ARP. TCP only, TCP, stuff like that. So fairly straightforward. Then there's the display filter syntax, which is going to be under analyze and then display filters. And then this is probably, oh no, it's not really that long of a list. So we can just go through the same thing right here. So I can just go to analyze, look at display filters, and we have all the display filters right here. And it seems kind of similar, but it's not identical, right? So TCP only does actually say TCP, and it was the same thing under capture, but when you want to look at Ethernet address, it's not the same, because the other one was ether something, and this is ETH.ADDR, two equal signs, so on and so forth. So they definitely are different syntax, so let's just make sure that we get that right. And then there's the operators, which is very, very important to understand, and this is something that seems to be pretty standard across most queries and most languages. So equal to is two equal signs. When you use one equal sign in most languages, in most programming languages, when you use one equal sign, that means you're assigning something to that variable. So let's say this is the variable, you use one equal sign, and then the value of the variable is going to be equal. In this case, when you use two equal signs, that it actually means it's equal that. So you're saying IP source equals to this, and then it's only going to show the stuff that shows up with this specific IP address, right? Not equal would be the exclamation mark and then the equal sign, and exclamation in most languages means not. So not equal. So you want to show everything. In this case, if you do equal to this IP, it's going to only show you stuff that's relevant to this IP. When you do not equal, it's going to show you everything other than this IP. It's going to show you all the stuff that this has nothing to do with this, right? Or at least the source IP doesn't have anything to do with that. Then you have greater than, pretty self-explanatory, less than, pretty self-explanatory. And so IP time to live, right? IP dot time to live greater than 250 seconds or maybe 250 milliseconds. Then less than, same thing. And then you have greater than or equal to. So you want it to be greater than or equal to whatever the number is, and then less than or equal to whatever the number is. And I mean, it's self-explanatory. I'm not going to spend too much time trying to explain that. Then you have logical expressions. And so logical expressions are when you want to combine two types of filters, right? So this is comparison operators, and for this one, it only shows this IP address. When you come here and you say IP source is this and the IP source is that, it's going to show you both, right? It's going to say both sets of IP addresses are going to show up. You say IP source is this or the IP source is that, it's going to show you either or. And it feels like it doesn't make sense because you can't have two IP sources being the and. So it feels like it's only going to filter for a packet that has both of those as the source IP address, which kind of feels like it doesn't make sense. When you do or, it's going to show you anything that has to do with this or anything that has to do with this. So this would bring you more options than this would in more practical situations. And then you have not, and the same thing is, not, exclamation would be not, and the logic is not. And so you can do this right here. So exclamation, and then you put this. So everything not that, right? The usage of not equals value is deprecated. Using it would provide inconsistent results. Using the not and then putting the value in parentheses is suggested for more consistent results. So we can't do not equals anymore, especially for this case. We would just do not and then put whatever the value is. For example, IP source equals yada 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 is going to be inside the parentheses. And this should give you, this specific thing should give you the same result as if you did a query like this, where IP source is not equal to that. It should give you a similar result, a similar set of results. And then we have the toolbar. So if it's green, that means you actually put in a valid filter. If it's red, that means it is not a valid filter. If it's yellow, it means it's a warning filter. It works, but it's unreliable, and it's suggested to be changed with a valid filter. So potentially this would probably work, but it would give you a yellow response. Let's actually try that, right? Well, no, I'm not gonna jump ahead. I don't want to jump ahead because when I do that, I get distracted. So I'm gonna stay on task here. So filter toolbar features are shown below. So when you type in IP, it'll give you all of the different options that are relevant to IP, and then you can use that as an autocomplete option. Then there is the clear filter, so it clears the filter. And then when you do the drop down menu, it'll show you what all of the different IPs or filters was that you ended up using and you actually searched for. So pretty self-explanatory. I'm not gonna really jump too deep into that. This was fairly understandable. And if you've done anything even remotely close to queries or stuff like that, this should be very familiar to you. All of this stuff should be familiar to you. The and or and all of that stuff should be very familiar to you. It's similar to searching through SQL and a lot of those things. They use similar types of things. Python uses similar types of syntax. So, it's good to know, good refresher, but I hope that you've seen stuff like that before and it's not your first time. All right, protocol filters. So still under packet filtering, but now we're looking at protocol filters. It supports 3,000 protocols, WireShark does. That's a lot. And allows packet level investigation by filtering the protocol fields. And this task shows the creation and usage of filters against different protocol fields. So IP would show all IP packets. IP.address equals this would show all packets containing the IP address, so on and so forth. IP address equals that, and then notice this right here where it puts 024. It would show all of the IP addresses in this subnet, right? Which could be anything from 0.2 to 0.255, I believe. So it's a lot of different IP addresses that could show up. And then you have IP source. So it's no longer IP address. You have IP source equals this. So it shows you everything that originated from that IP address, and an IP destination shows you everything that was sent to that address. And then you have IP address versus IP source or destination. The IP address filter in the traffic, the IP address filters the traffic without considering the direction. The IP source and destination filters the packet depending on the packet direction, which should be also self-explanatory. So when you do IP address, it shows you everything that has to do with this address, whether it's a destination or a source, right? Interestingly enough. And it's going to be 58,000 plus results. But when we go here and we do IP source, it drops down to 58. What? That can't be right. That doesn't seem like it would be right. It should be a different number of IP addresses that are shown. But this says, oh, no, I am so sorry. I apologize. I read the wrong number. So my bad. So IP address equals so on and so forth. It says there's a total of 58,000 packets, but there's been only 43 displayed. And then when you do IP address, IP source, there's only 20 displayed. And then when you do IP destination, there's 23 displayed. So that's my bad. I read the wrong digit. And so now we're going to look at TCP and UDP filters. So you have a TCP port equals 80. So everything that has to do with port 80. TCP source port equals that, so it's going to show all TCP packets originating from that port. Destination port shows everything going to that port. And then same thing with UDP. You have the UDP port, UDP source port, UDP destination port. So let me see if I can actually read this correct this time. We have, TCP port equals 80. It shows you everything that has to do with the TCP port equaling 80. So it would be a total of 58,000 packets. Then you do UDP port equals 53, shows you a total of 103 packets displayed. So it is filtering. So out of 58,653, there was 58,421 that was TCP, and then out of 58,653, there was 103 that was UDP, right? Then you have application level protocol filters, which would be HTTP and DNS. So HTTP response code 200 shows everything that has to do with the response code 200. HTTP request method GET will show you everything that has to do with a GET request. Post will show you everything that has to do with a POST request. DNS flag response equals 0 shows all DNS requests. DNS flag response equals 1 shows all DNS responses, because there's only one or the other. And then you have DNS query type equals 1. It shows you all DNS A records, right? So there's different types of DNS queries that can come through. There's two different types of flags, and then there's different types of queries that were done during DNS. And so if we look at this a little bit more in detail, you have HTTP response code equals 200, which means it was done okay, there was no problem with it. And so out of the 58,000 packets, there was 19 of them that were displayed. And then if we look at DNS flags response equals 0, which is a standard query, you have out of 58,000 packets, 54 of them are displayed, right? Then you have display filter expressions. So as mentioned earlier, there's a built-in option for display filter expressions that stores all supported protocol structures to help analysts create display filters. When an analyst can't recall the required filter, or is unsure, the display filter expressions menu provides an easy to use display for a builder guide. It's available under Analyze Display Filter Expressions, different from display filters, because there's three actually: display filters, display filter macros, and then the expressions. And then when you go through this, it kind of shows you what all of these different potential options are. So IP proto is protocol, and then IP proto equals is present, is not equal, greater than, less than, so on and so forth. So all of those things can work. And then so if you want to create one together, you would say IP protocol equals TCP, and then it shows you IP protocol equals 6. So that would be the filter that you would use. And then when you click OK, it would insert it into the search bar so that you can use it as a filter. So the first room introduced the coloring rules. Now you know how to create display filters and filter the event of interest. You can use the View Coloring Rules menu to assign colors to highlight your display filter results. So that's a customization kind of a thing. It has everything to do with your preferences and your personality, the coloring rules specifically. But this is actually very useful so that you can go to display filter expression, and when you want to search for something, and I'm pretty sure we're about to do that right now, is we're going to try to see what is the number of IP packets that shows up, what's the number of packets with a time to live value less than 10, what's the number of packets which uses TCP port 4444, HTTP GET requests sent to port 80, and the number of type A DNS queries. So we're about to go do all of that right now. So let's zoom out of here. Let's go into our tool here. We'll do OK. And let's load the questions. So the first one says, what is the total number of IP packets? And so if I just type in IP and press enter, it would give me a number. And so at the very, very bottom right here, it says packets 81,530, displayed 81,420. So 81,420 is probably the answer that we are looking for. So let's try that. And that is indeed correct. The second one is the number of packets with a time to live value that is less than 10. And so if you remember, we were doing some operators over there. And so under the operators, we want to find less than, so the less than sign, and then we just want time to live less than. So I think it's IP.ttl, and it's going to be less than 10. So if I press that, that should give me a certain number of results. Let's see what we get. So out of 81,530, there is 66 displayed. So since I have to kind of show you that, I'm going to shrink this so that we can easier zoom in to this bottom portion right here. So out of the 81,000 packets, there's 66 of them that have a time to live of less than 10, I guess. So we're going to go and answer that, and hopefully that'll be the right answer. And 66 is the right answer. So it says, what is the number of packets which use TCP port 444? 4444. So this, it doesn't say source or destination. It just says TCP port. So what we're looking for is the TCP port equals 4444 is going to be our search filter. So we're going to do the TCP, 2 equal signs, and then 4444, and press that, and that's going to give us a certain number of responses, and it says 0. So, oh no, you know what? I forgot to put, that's my bad. So TCP port, that should give us something. There we go. So 632 out of 81,000 are TCP ports. So let's see if that is the right answer. And that is. What is the number of HTTP GET requests sent to port 80? So we want HTTP request method equals GET, and then we also want port 80, right? So we're going to do, okay, so here's our filter right here. So HTTP request method equals GET, 2 ampersands would be AND, TCP destination port equals 80, because it's asking us how many were sent to port 80. So we want to see the destination port equaling 80. So I'm going to press enter on this and see what number we get. We get 527 displayed. So let's see if that's the correct answer here. And that is the correct answer. Great. So last question is, what is the number of type A DNS queries? So what is the number of type A DNS queries? And the filter for that is going to be this right here. So see, DNS query type equals 1. And we press that, and that should give us 106. So 106, let's see if that's the right answer here. Okay, 106 was not the right answer. So what I'm going to do is I'm going to combine the query that they taught us with another DNS query, which is the response flags. So we're going to do flags.response, and that's going to also equal to 1. So let's see if that gives us the correct number. And so that did shrink it down. It went from 106 to 51. And I want to say that might actually be the right answer. So definitely 106 wasn't. 51 is. Okay, great. So we were supposed to combine the two filters, although the question kind of is a little bit misleading. So what is the number of type A DNS queries? It's a little bit misleading because it doesn't say that you need to get the proper response, right? So shows all DNS responses. That's what flag 1 does. But I guess we could have tried either one. Just trial and error would have probably gotten us that answer. So either way, we are now officially done with the task that we're on, which is the port filtering, or excuse me, packet filtering, my bad, protocol filters. So now we're going to go into something called advanced filtering. All right, so far we have Learn the basics of packet filtering. Now it's time to focus on specific details for the event of interest. Besides operators and expressions, WireShark has advanced operators and functions. These advanced filtering options help us conduct an in-depth analysis of an event of interest. So there is the filter type, which would be the comparison operator. Description, so search value inside the packets. This is very freaking useful. It is case sensitive and provides similar functionality to the find option by focusing on a specific field. Then there's the example, so find all Apache servers. Then you have workflow, list all HTTP packets, where packets server field contains the Apache keyword, and then usage. Oh, I see. So this is just one. This is one specific filtering option, and we're looking for something that contains something. So filter contains. It's a comparison thing, and so the full thing would be HTTP server contains Apache. And so what it's going to do is it's going to go through everything that would have the HTTP server value or the parameter, and then from there it's going to search for the Apache value, and it would give you only one. And in this case, it would give you only one response instead of having to sort through a bunch of different things. And so what it does is it actually searches the contents of the packet and goes into server and finds something that has to do with Apache. And out of 58,000 packets, it displayed only one, which is pretty damn amazing. So now the next one is matches. So HTTP host matches this pattern, right? Or something that has to do with this. So you search a pattern of regular expressions. It's case sensitive, and complex queries have a margin of error. So for example, we want to find all PHP and HTML pages. So all HTTP packets where the packet's host field matches the keywords .php or .html. And so in this case, it's HTTP host matches / dot, and then you put it inside parameters separated with a little pipe. So PHP, HTML, and so it would look for everything PHP and or HTML. In this particular case, it looks like there's two pipes in here, so we might need to keep that in mind for the future. And then so it goes into the HTTP protocol right here, and it gets download, .html. It'll pull that up for you. And so out of 58,000 packets, we only got 20 displayed. And the next filter is in. So it says set membership. So TCP port in these different options, right? So list all TCP packets where packets port fields have values 80, 443, or 8080, right? Let's make sure that we extend the timer on our machine so it doesn't die on us too quickly. And so there we go. It's going to look for TCP port in, and then this is a list value. And so the list value itself, it's list formatting. In Python, they also use something like this, but it's separated by commas. And in this particular case, we're just using squiggly packets with no, or squiggly brackets with no comma separators. So this is what it would look like inside the actual search bar. Then it's going to look through the destination ports, going to give this particular packet is port 80. And then out of the 58,489. So out of 58,653, there's 58,489 that showed up, which is the majority of the packets showed up, which means because port 80 is HTTP, port 443 is HTTPS, and then 8080 typically is attached to some kind of a server. So they're very, very common ports, and they're used very frequently. So obviously out of the 58,653, 58,489, 99.7% of them are freaking showing up here. So then we have the upper function, or the upper filter, that converts all HTTP packets server fields to an uppercase and lists packets that contain the Apache keyword in uppercase. So upper HTTP server contains Apache. So now we're combining two filters, right? We're turning upper to the HTTP server value, and then we're saying it contains Apache as the term, and then it filters everything and it looks for a capital Apache for you. And so in this case, I mean, it's still showing the same freaking file. So this one doesn't seem normal to me. It doesn't seem logical, because I would think that it would search for something that's in capitalized or caps lock. But maybe what it means is that it will convert the field. Yeah, it doesn't make sense. This doesn't make sense. This one kind of doesn't make sense to me, but I'm pretty sure we're going to have to use it in a little bit. Now we have lower. So lower HTTP contains Apache, and then you just go through that, and it now shows you the same freaking packet. So maybe what it means is that if the search term is all lowercase, we can make sure that it searches for it. Doesn't matter, because they said the first one was case sensitive. So maybe in this case, what we can do is we can say, hey, listen, this whole thing is in uppercase, and I just want you to know that I'm submitting in uppercase, and I don't want you to be case sensitive. And so it will respond with something that, is not exactly all uppercase or not exactly all lowercase. Maybe that's what the use of that is. And then we're going to filter for a string, so it converts all frame number fields to string values and lists the frame list frames end with odd values. It's kind of odd, no pun intended. So string frame number, so whatever the frame number is, as we wanted to match this and search for this as a string, I think. So string matches this inside the frame. And so what it would do is it would look for 1, 3, 5, 7, 9, and 1, 3, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, so on and so forth. And it will show you, what else does it show? No, that's specific. That's basically it. So we're filtering the frame number, and it matches any of these things, being that it ends with any of those things. I think that's what this whole thing means. So, and list frames end with odd values. That's what this means. So if this was 24680, it would show anything that ended with a 2468 or a 0. That's what that means. And so it displays 29,000 filters out of 58,650, which is basically half of them, right? And then we have bookmarks and filtering buttons. So creating and using bookmarks would be probably something very useful. So if you want to save a filter, you can click on the little bookmark button, and you could save the filter, and it will save it to you as a new display filter. And we can come down here probably and change the name of it later on, so that we can search for it later, or we can just pull it up from the list that we have. So that's always very useful. And creating and using display filter buttons. So we would add a display filter button over here. That's the little plus sign right there. And then we would label it odd frames. Then we would attach that to that, and the comment would be such and such, and you would save that. And so now you have a odd frames button. That's how you would apply, or that's how you would quickly search for your filter. And then the odd frames button, you can click on it and it would say apply as filter, and then you can apply it as the filter, and it would now show up everything as such. Then we can go to edit configuration profiles and create a profile for configurations, and we could switch to any of these. So the default profile, the CTF for CTF exercises, network troubleshooting, threat hunting, Bluetooth classic, no reassembly. And these are previously made profiles, and you can create a new profile. So if we created a new profile, it doesn't show us what that looks like, but I guess we could create a new profile. We may be able to add what we just did. So it has a multifunctional tool that helps analysts to accomplish an in-depth analysis. As we covered, multiple preferences need to be configured to analyze a specific event of interest. It is cumbersome to rechange the configuration for each investigation case, which requires a different set of coloring rules and filtering buttons. This is where profiles come into play. You can create multiple profiles for different investigation cases and use them accordingly. You can use the Edit Configuration Profiles menu or the lower right button of the status bar to get to the profile section to create, modify, and change the profile configuration. And so now we have the questions for this particular task. Find all Microsoft IIS servers. What is the number of packets that did not originate from port 80? So we would use 2 filters most likely for this. Find all servers. What is the number of packets that have version 7.5? We'd probably use 2 filters for that. What is the total number of packets that use port 3333, 4444, and 9999? What is the number of packets with even TTL numbers? And change the profile to checksum control. What is the number of bad TCP checksum packets? And then use the existing filtering button to filter the traffic. What is the number of displayed packets? So let's go through this. This is kind of getting advanced as the name of the task implied. So let's go into our tool here. And now we are going to go into our second monitor and load the questions from the beginning so I know what the heck I'm looking for. Okay, so the first one seems to be kind of simple, which is what is all of them that are Microsoft IIS. Okay, let's try this one. Let's see if that brings up anything. Okay, so I removed Microsoft and then added the TCP source port 80 because that was the second part of the search that we were supposed to do. And so out of 81,000, we got 21. So let's see if this is the right answer here. Okay, cool, that's great. Now we're going to do Microsoft IIS servers with the number of packets that have version 7.5. So we're going to modify this. We're going to keep the first portion the same, and then we're just going to add a new little filter here. So this was not TCP port 80. So we're going to add matches version 7.5. And so that should bring us 71 results. So let's see if that's a good response. Okay, that did work. And now what is the total number of packets that uses port 3333, 4444, or 9999? So total number of packets that uses a port, TCP port, and it was the squigglies. So 3333, 4444, 9999, and then close squiggly. And that should be the filter. Let's see how many that gives us. 2235. Let's see if that's good. Oops. 2235. Okay, good. What is the number of packets with even TTL numbers? So this one I gotta get a little bit better at because I have no idea. This one was the one that kind of confused me a little bit. So it was they used the odd version of this. So we're gonna look for a string in IPTTL, so IP time to live, matches, and then we're gonna do a square bracket 02468, and then another square bracket, so the closing square bracket, and then a $sign, and then a closed quote. And so the IPTTL matches any of these. So now we see. This is kind of weird because it shows a bunch of stuff that doesn't have it closes with 789. So 02468 does not seem right. So let's see if this is, I guess I will see. So 77289, is that right? 77289. Yeah, but it's showing numbers that end with odd numbers. This is very weird to me. Why is that even working? It shouldn't work, or it shouldn't be the right answer because it's giving you all of the stuff. Yeah, okay, whatever. Oh no, dude, I'm looking at the wrong freaking column here. This is so obnoxious. I'm looking at the number column and I'm supposed to be looking at the time column. And so all of these, nope, this is not it either. We're looking for time to live. Is there a time to live uh, value? It's probably under here somewhere. Yeah, so time to live for this one ends in 8. And then if we go to another packet, time to live is 242. Time to live ends in 8. Time to live 242. Time to live 242. Again 128. 242. I mean they all end in 128 or 240. Oh, there we go. 40. Oh no, I'm sorry. 128 again. Okay, whatever. So it's between 128 and 242. But at least it worked. I was looking at the wrong thing. Sorry. Sorry, guys. Sorry. Moving to the next question. It says, check the profile to checksum control. What is the number of bad TCP checksum packets? And so it said there's, at the bottom right, we can click on default right here, which is the profile. And we want to check it to checksum control. And so the profile is going to update. And so we want, what is it? Bad packets. So does it tell us? So we have to go to analyze, display filter expressions, and try to find the checksum status. So it's going to be TCP checksum status, and then we can change that to bad. And so here we go. It's under TCP transmission control protocol, and then you scroll down and you find TCP checksum status equals bad, and then so we're going to do OK in this case, and that should add it to this thing right here. And if I press enter, should update our number of bad. So display 34185. I wonder if that is actually correct. So 34185. There we go. Okay, great. And finally, use the existing filtering button to filter the traffic. What is the number of displayed packets? So the button is available in the checksum control profile. The existing filtering button to filter the traffic. So this is the filtering button. It says GIF or GIF, whatever, JPEG with HTTP 200. So it's going to look for all of these things. That's the existing button. And then it's going to give us 261 displayed results. So let's see if that's it. And there it is. So we got all of the questions answered for our advanced lab right here. And we can now jump into the conclusion. So it was nice. This was a great learning lesson, or learning lesson. Goodness gracious. It was a great learning curve, a lot of lessons learned. And I really like the fact that WireShark has such in-depth analysis tools that we can use. So I learned a lot. I hope you learned a lot too. Let's jump into the conclusion of the room and let you move on with your life. All right, the conclusion is basically saying, hey, congrats, you finished. And in this room, we covered the stats, filters, operators, and functions. And so we're going to go into the very next room in the next video, which is going to be traffic analysis, which is probably going to kind of combine these two rooms that we just went through so that you can get a good holistic approach for traffic analysis. So I am very proud of you. Thank you for sticking it out with me. This was a great experience. I hope you also learned a lot as well. And yeah, this was one of the subscriber-only rooms that was available in TryHackMe. So it requires a subscription, but you can always just download WireShark on your own machine and mess around with it like that. The subscription is $12. If you use the link in the description below, it shaves off $7 off the subscription, brings it down to $7, so it makes it a little bit more affordable. And if you don't want to do that, again, you could just download WireShark on your own computer and go along with the exercises. You can capture some traffic from your machine and go through all of these filters and everything that we just did so that you can get a better understanding of how everything works. Like, subscribe, and turn on the notification bell so that you can get notified the next time that a video comes out, which is going to be the WireShark traffic analysis for this particular pathway. And then there's also the Pentest Plus pathway that I'm going through, so you'll get access to that information as well. And yeah, it'll be nice to have you as a part of the community, and so that we can run along together and learn some hacktivities, learn how to hack things and secure things, so on and so forth. This is your boy Hank Hackerson at Hank Hacks Hackers. If no one else loves you, Hank loves you. I hope you enjoyed it. I hope you learned a lot. Please leave any questions or comments that you have in the comment section below, and I'll try to get to them as fast as possible. And yeah, peace, love, and chicken grease. I will see you in the next video. Later.